Welcome to Department of Collegiate and Technical Education. As part of Learning Management System, Department of Computer Science and Engineering presenting session on Computer Organization 15CS32T, third semester. Today's session is on Unit 2, Session 4, Basic Instruction Types. Before starting today's session, let's have a revision on previous session. In the previous session, we have discussed about the following contents: register transfer notation, that is transfer of information in computer from one location to another location, represented by using a register transfer notation. The information may be from memory location or processor register or registers in IO device. The RTN, register transfer notation, the right hand side of the RTN represents the value of the memory location, and left hand side represents the location where the value need to be placed. Second one is assembly language notation. To represent instructions and programs in computer, the assembly language format is used. Assembly language uses the mnemonics to represent the assembly language notations. Mnemonics may be add, load, store, etc. By using that mnemonics of operation code with the operands, the notation can be represented in assembly language notation. In continuation of the previous session, today's session we will discuss about the following contents: basic instruction types, 3 address instruction, 2 address instruction, 1 address instruction, and 0 address instruction. Let's have a look at this. Basic instruction types. An instruction consists of two parts: an opcode to perform the operation and the operands upon which action is performed. The instruction basically consists two parts. One is the operation code, that is opcode. What operation it is performing, whether it is transferring content from memory location to processor register, or transferring the content from processor register to memory, or transferring the contents within the processor register itself, right? So that is the operation operation code, that is opcode need to mention, and the on which operands the operation need to be performed, that is the operands. So here example for the basic instruction is add a comma b comma c, where add is the opcode and a b c are operands. So this instruction perform the addition operation. So the operation performed in this example is addition operation on operands a b c. So here the three operands are used, a b c. In on a b and c, the addition operation is performed. So in this case, the operation addition is performed on a and b and store the result in c. The contents of a and b are added and store the results in c operand. The instruction types having four basic instruction having four types. One is 3 address instruction, second one 2 address instruction, third one 1 address instruction, fourth one 0 address instruction. Okay. Let's start with 3 address instruction. An instruction which has 3 address fields or operands is called 3 address instruction. The operands are number 3 here. The 3 address instruction which are having a operands 3 is called 3 address instruction. The general format for 3 address instruction is opcode, source 1, source 2, destination. Opcode means operation code, what operation need to perform. Source 1, source 2, destination are 3 operands. So in the 3 address instruction, there are 2 source and 1 destination. Example. Let's take add a comma b comma c. Here add is the addition operation. A and B are called source operand and C is the destination operand. So the contents of memory location A and B are added and stored in the memory location C. So this instruction add A comma B comma C does nothing but add the contents of A and B, store the result in C. So add A B C ಏನು ಮಾಡುತ್ತಪ್ಪ ಅಂದರೆ A C is equal to A plus B ಎಕ್ಸ್ಪ್ರೆಷನ್ ನ ಪರ್ಫಾರ್ಮ್ ಅಂದರೆ C ಗೆ A and B ಕಂಟೆಂಟ್ಸ್ ನ ಆಡ್ ಮಾಡಿ C ಗೆ ಸ್ಟೋರ್ ನ ಮಾಡುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ದ 3 address instruction. 2 address instruction. An instruction which has 2 address fields is called 2 address instructions. The general format for 2 address instruction is opcode, source comma destination. In 2 address instruction we have only 2 operands. So one is source and another one is destination. Opcode the operation code need to perform. Let's take a example for 2 address instruction. Example, add A comma B. So this instruction performs the operation in not an expression represented by B left implies content of A plus content of B. Here the contents of A and B are added and store the results in B. Here B itself is the destination. The contents of B are also considered and added with the A content and store the results back into the B. The operation add A comma B comma C is performed by, first we have to move the contents from B to C, then add the content of A to C and store the results in C. So this expression does nothing but first we move the contents of B into C, then add the content of A to C and store the results in C. Let's look at how this works. So we have the instruction move B comma C. Okay, let's take a B having some value 5. It need to move to the C. So C contains the B value 5. After move, then addition operation add A comma C. So this does nothing but add the A content into C content and store the results in C. So that is A is having value some 4 and add is the addition operation, that is plus, and C is having value 5. So these need to be added and store the results into C. So here C is 9. In move B comma C, B is source and C is the destination. The move B performs transfer of B content to C content, that is B value 5 is transferred to C 5. Then next add A comma C. So that is the addition operation. A is the source and C is the destination. In this case, the contents of A are added to the content of C and store the results in C. Okay. So in this case, A is having 4 is added to the C value 5 and store the results in C. That is C contains the addition of A and B. The 3 address instruction add A comma B comma C can be done by using these steps by using 2 address instruction. So 3 address instruction ಇಲ್ಲಿರೋ add a, b, c ನ ನಾವು 2 address instruction ಅಲ್ಲಿ ಈ ಎರಡು ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲಿ ಪರ್ಫಾರ್ಮ್ ನ ಮಾಡ್ತೀವಿ. The next one is one address instruction. An instruction which has one address field or one operand along with the operation code is known as one address instruction. So one address instruction is having only one operand along with the operation code. So here only either source or the destination. Okay. So one of the processor register known as the accumulator is used to hold second. So sometimes this accumulator register is used to hold intermediate as well as the final results. In one address instruction, as we have seen in the definition, it is having only one operand. So that operand, sometimes it is source operand, sometimes it is a destination operand. So the general format for the one address instruction is code source or destination. So either the operand can be source or the destination, only because it is only one operand. The other, if the operand is source, then some value need to be stored or some need to perform some operation, and destination should be some other thing. Here when the operand is source, the destination is accumulator. When the operand is destination, then accumulator is the source. Okay. Let's look at the example. Example, add a. Here a is the single operand, add is the addition. In this case, add the contents of memory location A to the contents of accumulator register and place the results in accumulator. In this case, A is a source operand. So the contents of A are added to the contents of accumulator. So and store the results in accumulator. So here the accumulator is the destination. The contents of A are transferred, added to accumulator register and store the results in accumulator register. So we have one address instructions can be load and store. So load and store operation also can have one address instruction. So let's see what is load A. Load A, copy contents of memory location A into accumulator. So when load A takes place, it copies the contents of memory location A into accumulator. So A is the source and accumulator is the destination. It copies the content from A location to accumulator location. Store A. So this instruction copies the contents of accumulator into memory location. So here A is the destination, accumulator is the source. From the accumulator content, the contents are transferred into memory location. Okay. Let's look at the 3 address instruction. Add A, B, C. So that is in register transfer. C left implies content of A plus content of B can be explained using one address instruction. We have discussed the 3 address can be represented by using 2 address instruction. So in the previous case, that is add A, B, C in 2 address instruction is first we have to move the content from move B to C, then add the content of A to C and store the results in C. That is 2 address instruction. The same instruction can be explained using a 1 address instruction. Is first load A, then add B and store C. Let's look at what is load A. Load A. So here the contents of A are transferred to accumulator. Okay. So we have A, we have content, and it is need to transfer to accumulator. Suppose then add B. The contents of B are added to accumulator. Then we have to store C. Then the accumulator content need to transfer into C location. So that is we have C, and this is transfer the accumulator content into C. First load A. So the A content is transferred into accumulator. Then B content are added with the accumulator content and store the results in accumulator. Then accumulator contents are transferred to a C location, that by using store. So this operation is same as add A comma B comma C. So that add A comma B comma C can be represented by using one address instruction. Is first load the content A to accumulator, that is load A, then add the content of B into accumulator, that is add B, and store the contents of accumulator into C location, that is store C. The operand specified in the instruction may be source or destination, as we have seen in the definition, right? Because it is only one operand, that operand can be the source or the destination. In the load instruction, address A specifies the source operand and the destination is the accumulator. Load A alli A ಅನ್ನೋದು source ಆಗಿರುತ್ತೆ, because it is only one operand ಇರೋದ್ರಿಂದ, so accumulator ಅವಾಗ destination ಆಗುತ್ತೆ. In store C instruction, C denotes the destination location, whereas the source is the accumulator. In store C, so it is only one operand. C ಏನೋ ಡೆಸ್ಟಿನೇಷನ್, ಸೊ ಅಲ್ಲಿಗೆ ಕಂಟೆಂಟ್ ಕಾಪಿ ಆಗಬೇಕು, ಇಲ್ಲಿಂದ ಅಕ್ಯುಮುಲೇಟರ್ ಇಂದ. ಸೊ ಅವಾಗ ಅಕ್ಯುಮುಲೇಟರ್ ಏನಾಗಿರುತ್ತೆ, ಸೋರ್ಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ಫ್ರಮ್ ಸೋರ್ಸ್ ಅಕ್ಯುಮುಲೇಟರ್ ಟು destination C location, the contents are transferred. That is the store C instruction. So access to data in the register is much faster than the data to stored in memory location. So the registers are having faster execution, so the access to data is much faster in register than memory location. So let's RI represents a general purpose register. Then the instructions load A comma RI, store RI comma A, add A comma RI. So instead of the accumulator here, the register RI is using to perform the same functionality as the accumulator. So this is load A comma RI, store RI comma A, add A comma RI are the generalization of load, store and add instruction for the single accumulator case. In this case, the RI performs the same function as accumulator. ಇಲ್ಲಿ ಅಕ್ಯುಮುಲೇಟರ್ ಬದಲಿ ರಿಜಿಸ್ಟರ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಆ ರಿಜಿಸ್ಟರ್ಸ್ ಅಕ್ಯುಮುಲೇಟರ್ ಫಂಕ್ಷನಾಲಿಟಿನ ಪರ್ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾವು ರಿಜಿಸ್ಟರ್ನ ಜನರಲ್ ಪರ್ಪಸ್ ರಿಜಿಸ್ಟರ್ RI ಅಂತ ತಗೊಂಡಿದ್ವಿ. ಕ್ಯಾನ್ ಬಿ R0, R1, R2, R3, R4, R5. So next is zero address instruction. An instruction without address field is called zero address instruction. So an address instruction does not have any operands, so no operands at all, right? So in this case, it is possible to use instructions where the locations of all operands are defined implicitly. So the operand location are defined implicitly itself in the instruction. In this case, the stack is used to store the operand. So stack is a data structure used to store the element, that is last in first out. So when the instead of element, when you thought of as a set of register, so on one top of another, so each register can store a value. So here the stack is used to store the register, so value that is on one top of another. A stack perform two principal operations, that is push and pop. So push operation insert the data element into stack. Pop operation remove the element from the stack. So these push and pop are the contents into or from out of the stack. Okay. Let's have a summary on the today's session. So in three address instruction, we have an operation code and three operands, that is op code, source 1, source 2, destination, and two address instruction which has op code and two operand. So the operation code source comma destination, one address instruction which has op code and one operand. Zero address instructions are used in stack operation. Stack perform the push and pop operations. Let's have a discussion on different multiple choice question based on today's session. The first question: operations are used in zero address instructions. A push, B pop, C both A and B, D none of the above. Okay. So zero address instructions is performed by using stack. Stack performs push and pop. So the option C, both A and B. Question 2. Number of operands in 3 address instructions are option A 2, option B 3, option C 4, option D 1. Number of operands in 3 address instruction. As we know, 3 address instruction is having 3 operands. The answer for this question is B. Add R1, R2 is a dash address instruction type. Option A 1, option B 2, option C 3, option D 0. Add R1, R2 is a dash address instruction type. So obviously it is having 2 operands. It is a 2 address instruction. That is answer B. 4. One address instruction contains dash. Option A opcode 1 operand. Option B 2 operands. Option C opcode 2 operands. Option D none of the above. One address instruction contains opcode and 1 operands. So option A is the right answer. Accumulator is used in which address instruction? Option A 1, option B 2, option C 3, option D 0. Accumulator is used in which address instruction? So accumulator is used mainly one address instruction, because one address instruction is having only one operand. The other operand is the accumulator. So answer for this is A1. Sixth, expression B that implies content of A plus content of B can be represented in 2 address instruction type is add B comma A, B add A comma B, C add both A and B, D none of the above. So this performs add the content of A and B and show the results in B. So correct representation in 2 address instruction type is A. No, A is adding content of B and A and store it in A. So it is the wrong, because our question is it stores content in B. So option B add A comma B. Yes, here it is add the content of A and B and store the results in B. So answer is B. Single address instruction add A means add the content of memory location A into the contents of accumulator, add the content of accumulator to the memory location, add the content of A and store results in A, D none of the above. Add A means add the contents of memory location into the contents of accumulator. That is option A is the right answer. 8. Any instruction add A comma B comma C. Which of the following is correct? Option A and C are source operands, B is destination operand. Option B, A and B are source operands, C is destination operand. Option C, B and C are source. Question number 8. In instruction add A comma B comma C. Which of the following is correct? Option A and C are source operands, B is destination operand. Option B, A and B are source operands, C is destination operand. Option C, B and C are source operands, A is destination operand. D none of the above. In instruction add A comma B comma C. A and B are source operands, C is destination operand. So option B is right answer. Question number 9. Dash instruction copies the contents of accumulator into memory location. Option A load, option B store, option C add, option D none of the above. Store instruction copy the contents of accumulator into memory location. So load it transfer from memory location to accumulator. Answer for this is store instruction. Answer B. Question number 10. Instead of load or store, which instruction is used? A. LOC, B. Add, C. Move, D. None of the above. LOC is location, it is not the instruction. Add, addition operation. Move, it transfer the content from one location to another location. So it transfer from memory to register, and maybe register to memory. So those load or store can be executed by using move. Option C is the right answer. Thank you.